And now we enter the topic thin layer chromatography. So it's one of the simple example of the chromatography. There are a lot of chromatography like column chromatography, paper chromatography, etc. But now we will only talk about the thin layer chromatography. Thin layer chromatography is a separation method or identification method of a mixture of a component into individual components by using finely divided absorbent solids spread over a plate and liquid as mobile phase. So this thin layer chromatography, or we can also call it TLC, is based on adsorption or an partition so that it will have a strong relationship with the polarity. So if we talk about the TLC, so it will all about the polarity of the compound and also the mobile phase. So different compounds in the sample mixture travel at different rates due to their differences in their attraction to the stationary phase and the solubility in the solvent. So separation and TLC involving the distribution between two or more substances in the stationary phase and also the mobile phase. So the stationary phase is a layer of the adsorbents. Usually we use silica gel or alumina, the aluminum oxide, coated on a plate. So it was using a glass plate, but now we also use the aluminum plate and also the plastic plate. And then mobile phase is developing liquid which is travels up the stationary phase and then carrying the samples with it. So the component of the samples will be separated on the stationary phase according to how much they absorb on stationary phase and how much they dissolve in the mobile phase. This is the scheme that I got from Khan Academy. So for example, in a leaves, it contains a lot of the components. So not only the chlorophyll, but also some other components. So when we want to check what is the component of the leaves of a plant, so we can use the TLC. Then you put it in the stationary phase. So in here, this is the stationary phase. For example, it's the chromatography paper. But for the TLC, you can use the silica gel plate. And then you put the propanone as the mobile phase in here. And then you spot the sample. So when it tries to travels, you can see a lot of colors inside. So not only the chlorophyll, but also like the carotenoid, the xanthophylls, and other like the anthocyanins. You can find it in the TLC. So you can have a result like this. First is the stationary phase. To obtain a good separation for the result, so the mean particle size distribution, also the morphology of the particle used in the stationary phase must be considered. And you also have to note that the surface must be flat without any irregularities. So in the present, it's really easy to find the stationary phase. To use the stationary phase, you can just buy it like the TLC plate with the alumina plate in the backboard. So it's not necessary to make it by yourself. But some times ago, or maybe some place still use this method, they make the stationary phase by themselves. And it's not a simple thing because you have to do this fourth step in the making stationary phase. So the pouring, dipping, spraying, and spreading. So first is the pouring. So the adsorbent of the finely divided and homogeneous particle size is made into a slurry and then it's poured to a plate and allowed to flow over so they it is evenly covered the plate. And then the next step is the dipping. This technique is used for small plates by dipping the two plates at a time, back to back in a slurry of adsorbent in chloroform or other volatile solvents. And exact thickness of layer is not known, and evenness of the layer may not be good. And then the next step is spraying. So the slurry is diluted further for the operation of the sprayer. But this technique is not used nowadays as it's really difficult to get a uniform layer. And then the next one is the spreading. So modern methods utilize the spreading device for the preparation of uniform thin layers of glass plates. And the commercial spreaders there are two types of the commercial spreaders. There are moving spreaders and the moving plate type. And this spreading will give the layer thickness from 0.2 until 2 millimeters. And then if it's not good enough, if it's not uniform, or if the surface has a lot of irregularities, so you have to do it again and again. You have to do pouring again, dipping, spraying, spreading, and pouring again until you got the nice one. And then after these steps, the next thing that you have to do is the activation. So after spreading, plates are allowed to dry in air and further dry and activated by heating it until about 100 degrees for around half an hour, like 30 minutes or 45 minutes. And by removing the liquids associated with the layer completely, so the absorbent layer is activated. The next component used in TLC is mobile phase. So the mobile phase should follow these requirements. First is the adequate purity and then adequate stability, and it has a low viscosity, and then the linear partition isotherm, and the vapor pressure is neither very low nor very high, and it has a toxicity as low as possible. And how to select the suitable mobile phase? So you have to look to these four factors. So first is the nature of the substance to be separated, and then the nature of the stationary phase used, and also the mode of chromatography that you want to do. Is it normal or reverse phase? And the next factor is the separation to be achieved. What do you want to do with the separation? Is it for the analytical or is it the preparative separation? And you should put it in note that avoid the use of water and other highly polar solvents. Why? Because it may loosen the addition of a layer of glass plate, so the silica gel will be dissolved in the water and high polar solvent, and then it will not give a good result for your TLC. So this is the diagram of the solvent polarity that may help you to find the good mobile phase or the suitable mobile phase for your TLC analysis. So you can see that water is in the top, so you can't use water in the TLC, and it will be better to use from the acetonitril to below until the pentane. And you can also use the combination between two or three solvents or maybe four solvents to give a good separation result in your TLC plate. For example, like the commonly used is the combination between methanol and chloroform, or between the methanol with the dichloromethane, or the ethyl acetate with the dichloromethane, etc. You can use any combination.